Welcome to week 4 of our course. I want to start off by just recapping our journey to this point a little bit as a reminder of where we've been, and then point a little bit to where we're going this week and in the following weeks. Even before the course started, of course, we had some video clips on the overall goals of the course, a big one being a deeper understanding of Einstein himself, and more particularly his special theory of relativity. We talked about that sometimes involves a struggle for understanding, as Einstein put it. And that struggle, though, can be an ennobling experience and an enriching experience as we try to lift the veil a little bit of the mystery, again, as Einstein put it, the mystery of the marvelous structure of reality. We also talked about how to succeed in the course, the idea that it's a construction process, really, that we're building new mental models, and we've got to lay the foundations first and then build on top of that piece by piece. And so we start off in week 1 looking at Einstein in context, and more generally the context of physics throughout the 1800s leading up to Einstein, and also some of the technology that came into play. So we looked at that and a little bit more of the miracle year itself in 1905, what that involved. Then we moved on in week 2 and looked at definitions of what does it mean to have an event, and how do clocks figure into that? How do we specify the location and time of a given event? And so we looked at frames of reference, space-time diagrams as tools by which we can visualize events in space and time a little bit better, and also talked about the principle of relativity in that context. Then in week 3, we went on and considered the second key principle in the special theory of relativity, the principle of light constancy, which meant we talked about waves more, light waves, how waves work in general. That got us into a discussion, conversation perhaps about the ether, a couple well-known experiments, the results, such as the Michelson-Morley experiment, stellar aberration, and just the puzzle involving all these things put together. How in the world do you understand what this ether is all about with these somewhat conflicting results that they were getting in the later 1800s with this, right about the time when Einstein appeared on the scene? And I imagine that some of you at this point are saying, when are we going to get to the good stuff? When are we going to get to the cool stuff, the weird stuff? Well, this week is when the weirdness begins. And so we're going to actually look at this whole idea of time is suspect. But before we get to that, let me just do our quotes of the week here. First quote, again, you can see these on your weekly handout. First quote is the eternal, from Einstein, of course, the eternal mystery of the world is its comprehensibility. The fact that it is comprehensible is a miracle. This is somewhat similar to the quotes we had a couple weeks ago about simplicity, and we talked about beauty, how many physicists look for beauty in their equations with the underlying assumption that somehow, if you have a beautiful equation, that must connect with the actual physical reality. And Einstein is reminding us here that is just an incredible mystery. Why should our math work so well? Why should people talk about the unreasonable effectiveness of mathematics in terms of matching up with physical reality? Doesn't mean that all math matches reality, but a lot of it seems to. And Einstein is pointing out that eternal mystery here, just a good reminder as we think about these things. Second quote of the week we'll do is gets at something else that really isn't part of this course, but it's a good reminder of another aspect of Einstein's life and work. He says, "My scientific work is motivated by an irresistible longing to understand the secrets of nature and by no other feeling." So that we're really seeing in our course. Irresistible longing to understand the secrets of nature. But then he goes on and says, "My love for justice and the striving to contribute toward the improvement of human conditions are quite independent from my scientific interests." And what this does is it reminds us that, as you may know, when Einstein became a world figure starting in the 1920s, a lot was going on then. And he spoke out on things against war and militarism and some of the other things going on, the anti-Semitism in Germany, and he was greatly affected by it as well. He had at least one lecture he was given, a public lecture, that was disrupted by anti-Semitic protesters. This was during the rise of Nazism in Germany in the 1920s and into the 1930s. His life was probably in danger at certain points, and eventually he ended up having to leave Germany for good. So, love for justice, striving to contribute toward the improvement of human conditions. He's saying it was independent from his scientific work. And that's a good reminder. Sometimes we want to tie up everything up in a nice little ball in terms of a person's life and work, that if he's doing this great scientific work, it must have some connection to his other work as well, maybe principle of relativity, everything is relative or something like that. In actual fact, that may be true, but it may not be true. And in Einstein's case, there was more of a disjunction between his scientific work and his work for justice and speaking out on those types of issues. So, quotes of the week there. We could add another quote of the week, perhaps, although we've talked about this before, that in 1905, he had been struggling with these notions of these two principles, the principle of relativity and the principle of light constancy, and saw that they were in conflict with each other, that there were some asymmetries involved in the theory of electromagnetism in particular, and then also trying to apply the principle of relativity to that electromagnetism seemed to imply there was an absolute reference frame, in other words, the ether, that on the other hand, and that came from the principle of light constancy, light as a wave, there must be some medium through which the light moves, and yet the principle of relativity, which is well established as well throughout physics, said, no, there is no absolute frame of reference. And so he's struggling to bring these two principles together. And in a conversation with Michael Besso, his friend from the patent office, or who was working at the patent office at that time, they'd been friends before that, in one of the discussions, he went home after it and came back the next day and told Besso that, I figured it out. You helped me. I had that flash of insight. And then later on in his life, when he was reminiscing about this, he said he realized that time was suspect. So that's what we're going to explore this week to start off with, and then see what he means by that and see where that takes us.